Hi there, we're Team 21 and we'll be focusing on the challenges of using natural gas as a fuel source. Our group members are James Doherty, me, William Downs, Sean Malone, Aaron Miller, and Nita Williams. So in order to run a vehicle off of CNG, they will need to be equipped with a monotronic control unit for natural gas, a CNG fuel rail, an NGI2 CNG injectors, CNG premium pressure and temperature sensors, and a high pressure sensor. So the way a CNG engine works is during the drive, a biofuel system can switch from natural gas to gasoline operation with no change in torque. During CNG operation, fuel lines conduct natural gas from the fuel tank where it is kept under high pressure to the pressure regulator. The high pressure level continually monitors pressure levels in the high pressure system. Within the pressure regulator, the natural gas is brought from the 200 bar down to 10 bar. From here, the natural gas is conveyed via the CNG fuel rail to the injection valve. The CNG medium pressure and temperature sensor measures the temperature and the pressure in the rail system. According to exact specifications, the injectors NGI2 now inject the natural gas into the intake manifold. The resulting natural gas air mixture is then ignited by a spark plug. The monotronic control unit for natural gas handles energy or engine management throughout the system. Now let's talk about the cost of CNG usage in vehicles. The primary driver behind why companies would want to use natural gas as a fuel in vehicles is because of the difference between the cost of diesel or gasoline compared to the cost of CNG. All natural gas projects require an upfront investment that needs to be paid off with that fuel savings, and that fuel savings have been consistent and growing over the years, and the EIA project that it'll continue growing even more. However, there are challenges faced when implementing a new design. In order for transportation vehicles to run off CNG, a conversion kit installment on cars is necessary. Conversion kit manufacturers that make kits to convert gasoline engines to use CNG will require an upfitter's cost to put the kit on the vehicles. This obviously increasing cost. Each kit engine combination requires a certificate of conformity from the Environment Protection Agency, basically saying that it meets the emission standards. But that also kind of limits the number of vehicles being offered as a CNG version. The cost of CNG vehicles depends on the size of the vehicle and the range the vehicle needs to travel. The size of the vehicle matters because smaller vehicles traditionally use a gasoline engine. Gasoline is simpler and cheaper to convert to a natural gas engine because it's spark ignition. You also have a lot of the same attributes and components of the engines. Larger vehicles, however, use a diesel engine which relies on compression and ignition, so having to change the ignition in the engine is going to drive up cost because it is going to require more engineering. Looking at the range, the more it needs to drive, the more tanks, or the more storage capacity you'll need on the vehicle, which will also increase startup costs as well. When looking at a small vehicle, it would need about a range of 250 miles, while medium would need about a 500, and then the 18-wheelers could be 500 to 1,000 mile range.
Now to address light-duty vehicles. Natural gas vehicles have been in the spotlight in recent years as the government and automakers have looked for alternative fuel possibilities to power the constant demand for vehicles with less of an environmental impact. As a fuel with renewable aspects and that creates less emissions, natural gas seems like a decent solution to this problem. However, the whole process is still pretty underdeveloped and therefore decently more expensive than with conventional vehicles. As with hydrogen and electric-powered vehicles, NGVs are mostly sought out by private, wealthy companies or individuals. The assembly of a natural gas-fueled car tends to be about $5,000 more than an equivalent model gasoline-powered car. If a buyer would choose to install a home refueling system, it would cost roughly another $5,000. Though an expensive option, The lack of public refueling stations across the nation make home refueling more popular. The compressed natural gas system has a lower density than gasoline, which requires that vehicles have larger fuel tanks. The CNG tank has an expiration date dealing on what company constructed it, or depending on what company constructed it and by which method, but on average is anywhere from 15 to 25 years. During its lifetime, an NGV fueling system needs more regular maintenance and proper decommission when it expires. CNG also has a shorter range per tank due to lower fuel density. The cost of converting the current industry of personal cars from gasoline to natural gas makes it very unattractive. This may change as gasoline becomes more expensive and the natural gas industry grows locally. Now, as for heavy vehicles, natural gas fuel sees most of its efficiency with heavy vehicles used for commercial and public use. Heavy CNG powered vehicles are under the same limitations as cars, and maybe even more as the hauled weight calls for almost daily refueling. Many companies, such as the Center Area Transportation Authority, CATA, have been using CNG for their fleet for many years. The biggest potential for natural gas is with long-haul trucking using liquid natural gas. Liquid natural gas is roughly a time and a half more dense than gasoline. This increases the range per tank of fuel and solves the problem of refueling stations and low range of CNG. Specialized refueling stations already in place for large vehicles, such as tractor trailers, can more easily have a natural gas option implemented into the existing infrastructure. This will allow these trucks to span the country on natural gas. The upfront costs to convert fleet vehicles to natural gas can be offset by lower operating and maintenance costs over the lifespan of the vehicle. The payback period depends on the fleet's average distance traveled, requiring refueling infrastructure costs and other considerations. A truck running on liquid natural gas will begin making a profit in just 5 years after purchase. Unfortunately, the infrastructure is still underdeveloped and not readily available. There are under 100 public LNG stations according to the Alternative Fuel Data Center, and the construction cost of each station ranges from $1 to $4 million. A number of concerns arise when it comes to vehicles with natural gas tanks and engines. For instance, a car collision where the fueling system becomes compromised can be dangerous for all, especially those unfamiliar with NGVs. It is crucial to notify those on the scene, including any first responders who are very up close and personal with the vehicle involved. It is also pertinent to properly identify what type of natural gas the vehicle runs on, so that the respective measures can be taken in order to stay safe. It suggests that the vehicle can be inspected before returning to the road, so it's best to get a tow instead of taking chances. Liquid natural gas is stored and remains at extremely cold temperatures. It is significantly more dense than air and tends to puddle up in fog clouds near the ground when it leaks. This fog is incredibly dangerous and needs to be avoided until it can be properly contained or removed from the scene. Compressed natural gas is a lot less dense than its liquid counterpart, and air alike, so it most often dissipates into the atmosphere when it leaks. Any amount that remains tends to give off an odor like rotten eggs, which is easily identifiable. As with conventional fuel, both types of natural gas are flammable and dangerous when in contact with skin, as well as when fumes are inhaled. Refueling possesses its own set of concerns. CNG is much different than octane in the sense that it expands and contracts with changes in temperature. On a hot day, a CNG tank may hold up to 75% of its full potential. As the fueling rate increases, so does the temperature of the fuel, which causes a discrepancy in the amount of fuel one gets versus how much they should. For this reason, time fill pumps are available alongside the fast fill pumps for those not in a rush. The overall newness and differences between fueling conventional fuel and natural gas is often is enough to cause difficulties. If we have learned anything from Oregon in the last year, it's that teaching people how to fill up their tank isn't always easy.
Energy security for the United States, once considered an impossible goal, is now within our reach with the abundant supplies of natural gas available today in North America. We've been using natural gas in our homes and businesses for heating, hot water, and cooking for more than 100 years. But natural gas can also be used to fuel vehicles. Compared to some other vehicle fuels, natural gas is clean, abundant, affordable, and American. Recent technological and economic developments are providing greater access to large reserves of natural gas under North American soil. Today, these reserves are projected to meet U.S. energy needs for generations to come. Natural gas vehicles, which are sometimes referred to as NGVs, have been around for decades, operating on roads around the world. NGVs are available in all vehicle classes, including passenger vehicles, transit and school buses, refuse, and heavy-duty trucks. NGV engines operate in a manner that is very similar to gasoline or diesel engines, except that natural gas combusts in gaseous form rather than as vapor. NGVs are available in two basic configurations: dedicated NGVs and bifuel NGVs. Dedicated NGVs run on one fuel only, compressed or liquefied natural gas. Bifuel NGVs have internal combustion engines that run on natural gas and gasoline. With bifuel vehicles, the two fuels are stored in separate tanks and the engine runs on one fuel at a time. Factory-built NGVs are available from various automotive manufacturers. Additional vehicles that are powered by compressed natural gas are also available through a conversion process. One of the benefits of NGVs is the price advantage that they offer over gasoline and diesel-fueled vehicles, which can be significant. Natural gas is less expensive than other vehicle fuels, and its price is less affected by the unpredictable changes in the world's oil market. As a result, drivers of natural gas vehicles can save 40 to 50% per gallon at the pump compared to gasoline and diesel. This price difference can result in significant fuel cost savings year after year. Large transit or trucking fleets switching to natural gas can save millions of dollars per year. In recognition of their environmental benefits, solo drivers of NGVs are allowed to use the HOV or carpool lanes in several states. Natural gas vehicles have a safety record similar to vehicles powered by other fuels. The fuel tanks or cylinders that hold the natural gas fuel on the vehicle feature robust designs and are engineered to provide years of reliable service. Natural gas is one of the cleanest alternative fuels today. NGVs produce fewer smog-forming pollutants compared to most diesel and gasoline vehicles on the road. Renewable natural gas, or biomethane, is an even greener fuel by offering reduced greenhouse gas emissions, which contribute to climate change. There are more than 15 million natural gas vehicles already in operation around the world today. These numbers can only continue to grow as more NGV options become available and consumers recognize that natural gas for vehicles is clean, abundant, affordable, and American.
All right, now to address the issue of using natural gas to fuel planes. So for using natural gas, or more specifically liquid natural gas to fuel planes, it's already in development. The issue as to why it's not spreading as quickly as it did for trucks and buses are the following. The natural gas industry at its current state does not allow it to expand. There are specific parameters that need to be followed in order to use liquid natural gas for plane fuel, and there's a lack of technology that prohibits us from actually using it safely for planes. Now, the issues surrounding natural gas for planes falls into three different categories, as I just mentioned. The first being the natural gas industry, being that there's not as many natural gas suppliers as there are fuel suppliers.
So you'd have to actually increase the number of stations in order to actually get enough natural gas to fuel planes to actually make them more frequent than jet fuel planes. Another is that natural gas needs specific parameters in order to be used safely. One of the largest barriers to overcome is the fact that liquid natural gas reacts violently with water. So if there's any sort of liquid that could get in either during flight or any sort of crash that would involve water, since crashing in planes in the water is much more safer than crashing on land, the chance that you have a crash that would want to land in water, except for when you have natural gas, if that breaks, it becomes very violent and violently reacts with water, and it's a lot less safe than it would be for jet fuel. Another thing is that liquid natural gas needs to be kept at specific pressures throughout the entire flight, even though the plane is changing pressures as you fly, as you make your entire flight. You need to keep the liquid natural gas at the exact same pressure the entire time in order to reduce the possible dangerous side effects of using liquid natural gas. Another thing is that safety tests, in order to actually implement liquid natural gas into planes, would take about 5 to 7 years to even complete before liquid natural gas planes could even hit the market. The last thing is that the technology isn't there. One of the things that we would actually have in order to use liquid natural gas for planes is we would need a superconducting system to keep it at the correct temperature. So not only do you have to keep it at the right pressure, but you also have to keep it at the right temperature, which is negative 200 degrees Fahrenheit or lower. So you actually need a superconducting system rather than just a typical cooling system, which is not readily available with current technology, or it may be, but it's not safe to use in air travel. Boeing is actually attempting to create a liquid natural gas plane, calling it Project Sugar Freeze, but they claim the technology that we currently have does not allow for safe travel as opposed to jet fuel. They also estimate that the technology needed to use liquid natural gas with planes will not be available until 2040. Now, while there are issues with using natural gas for planes, there are obviously many benefits. One of the benefits being that liquid natural gas evaporates quickly when exposed to ambient temperature, and it will not pool dangerously like traditional jet fuel. So in the case that you end up getting in a crash again, say it's on land, you wouldn't have pooling like you would to jet fuel if the fuel line breaks. The liquid natural gas would just evaporate and you wouldn't have any danger of explosions, or you would have a much more reduced chance of explosions. Liquid natural gas also has a higher ignition temperature. Again, you would have a less likely chance of an explosion as opposed to jet fuel. The liquid natural gas will not combust as easily. It is also much more fuel efficient than jet fuel, which is the primary reason for switching from jet fuel to liquid natural gas. Boeing predicts that they will actually reduce the fuel burn by 57% by using liquid natural gas instead of jet fuel. John Gibbs, liquid natural gas plane entrepreneur and former Boeing employee, estimates that using liquid natural gas instead of jet fuel will yield 50% savings after factoring in infrastructure costs. Natural gas as a transportation fuel source has been around since the 1930s. According to the Natural Gas Vehicle Coalition, there are more than 150,000 natural gas vehicles on the road today. However, even though natural gas technology has improved in recent years to allow for proliferation of natural gas vehicles, there are still some challenges that the natural gas vehicles face when it comes to infrastructure and practicality of using natural gas as a fuel source. As a transportation fuel source, it has a few similarities to gasoline. For example, a compressed natural gas tank is a storage device of similar size and shape and can be stored in the same locations as on a gas car. Also, a compressed natural gas tank can be filled in a similar manner as a gasoline tank as well. However, the disadvantages natural gas faces in the transportation field are substantial. A few examples of problems these vehicles face have to do with the infrastructure and economic drawbacks surrounding using natural gas as a fuel source. Natural gas infrastructure in the United States is far less developed than it needs to be in order to grow an aggressive expansion in the transportation sector using natural gas as a practical economic competitor to gasoline. Some of the challenges facing natural gas vehicles are a higher initial cost of ownership, a very limited refueling infrastructure, and some of the performance characteristics of natural gas vehicles. Initial cost of creating a natural gas vehicle is generally higher than its gasoline counterpart. A study in the University of California shows that the differences between price in between two identical models. The 2014 Honda Civic is a difference of over $8,000, more than 40% more than its gasoline counterpart. Even so, as technology behind these cars continues to improve, the production costs may fall, and these vehicles could start to compete more with the prices of gasoline cars. Arguably, the largest challenge facing expansion of natural gas vehicles is the lack of refueling sources in the United States currently. There are about 1,500 fueling stations dotted around the country, only about half of which are open to the public. By comparison, even after declining in the past 10 years, the number of gas stations today is around 168,000. Finally, the lack of range of natural gas vehicles makes them difficult to rely on for trips of significant distance because of the lack of infrastructure surrounding these vehicles. However, once these challenges are overcome, natural gas can be more economically practical than gasoline, especially for vehicles that are focused around using high volumes of fuel like taxis, semi-trucks, and buses. In the past, natural gas vehicles have been about 30% less expensive than gasoline vehicles to refuel, and in many cases, the maintenance cost for natural gas vehicles is less over time than their gasoline counterparts. In a more macro sense of economics, natural gas vehicles have the ability to reduce the United States' dependence on foreign oils, creating a safer and more stable energy supply in the United States.
In addition, on average, compressed natural gas prices are much less volatile on average than gasoline. A large reason for this is because of the politics of trading and deals around the world. While crude oil is largely supplied to the U.S. from outside sources, the reserves of natural gas inside the U.S. are large and the potential for more supply is great, so prices have been in the past and continue to be much more stable than gasoline.
And here is a quick video to help explain a little bit more about using liquid natural gas or compressed natural gas in transportation.
Gas Networks Ireland own, operate, build and maintain the natural gas network in Ireland and connect all customers to the network. We ensure the safe, efficient and secure supply of natural gas. Compressed natural gas is a global alternative to diesel or petrol as a transport fuel. It's the same natural gas used to heat our homes or cook our food. It's simply compressed to fit in the fuel tank of a natural gas vehicle. It's a proven, reliable technology used in over 19 million vehicles worldwide and 1.9 million vehicles in the developing European market. So here's how it works. Natural gas is transported through existing gas pipeline infrastructure to a CNG refueling station. Here, the gas is compressed and stored before being distributed to a natural gas vehicle through a natural gas dispenser. After the CNG enters the vehicle, the natural gas engine operates much like a diesel or petrol engine, with the only differences being the fuel line and fuel tank. Natural gas is pivotal in the future of transport. CNG in transport is a global alternative to diesel or petrol, offering a cleaner, cheaper and proven fuel solution for your fleet of trucks, buses and vans.
So now we'll talk about natural gas supply. As previously mentioned, the availability of natural gas as transportation fuel relies on the proper infrastructure being available. The number of active rigs in the United States has decreased dramatically over the last decade. In 2007, there were about 1,450 rigs operating across the nation, but last year, less than a seventh of that number were active. Despite this, significantly more natural gas is being consumed today than a decade ago or in the years before. In 2007, 23,100 billion cubic feet of natural gas was consumed, 646 of which were for transportation purposes. In 2017, 26,800 BCF were consumed, and about 728 were used in transportation. Many stations in the U.S. are privately owned, but there are currently 931 compressed natural gas stations and 73 liquid natural gas stations available to the public. This number is expected to increase in the coming years. So, new developments. The nation has been incentivized to turn to natural gas as a fuel alternative. Federal laws and taxes have been set in place in order to bolster new interest in NGV. The Alternative Fuel Excess Tax Credit ran up through December of 2017 and gave a tax credit of 50 cents per gallon of natural gas. The natural gas vehicle weight exemption allows NGVs to exceed the federal maximum gross vehicle weight limit by the amount equal to the difference in weight from the natural gas fueling system to a diesel fueling system. These vehicles now become preferable to fleet drivers that carry freight and travel long distances. Aside from this, the Environmental Protection Agency has gotten involved in many efforts to reduce emissions through transportation, including the National Clean Diesel Campaign that regulates diesel engines and fuels. As we have mentioned in class, the EPA has also regulated the renewable fuel standard that requires that a certain amount of renewable fuel be injected into transportation fuels in order to have cleaner exhaust and reduce our reliance on foreign countries for imported oil. The 2018 fuel volumes have been finalized so that by the end of this year, 19.3 billion gallons of total transportation fuel come from renewable sources. This amounts to 10.7% of total fuel volume. The nation has become increasingly interested with natural gas production for many reasons. The Renewable Fuel and Cleaner Emissions campaign to stop global warming has played a huge factor in our country's step to take action. Under the Trump administration, it has been made clear that domestic energy production is a priority, and natural gas is something we can make at home with a more stable market than traditional fuels that rely on foreign oil imports. Aside from this, the general population can be pleased to find natural gas fueling systems in their favorite vehicles, from the Ford F-250 Super Duty to the Dodge Ram 2500. A more recent development has found that we can produce renewable natural gas from purified biomethane. Once collected from using cooking grease from restaurants across the nation, biomethane is largely produced in the decomposition of organic materials. The anaerobic digestion of this material breaks it down into its simplest components, the majority of which is methane. Landfills, wastewater treatment plants, and livestock operations are the big player in this game. The Vehicle Technologies Office has identified over 300 landfills that actively produce biomethane, each up to 20,000 gallons of LNG per year. Large farming operations use manure digesters to produce methane that in turn powers appliances and provides other benefits to the farm. Only a portion of this power is used, which allows the rest to return to the grid, or in our case, remain as biomethane to purify for transportation fuel. Landfills and livestock facilities alike use this technology to power local natural gas vehicles such as refuse haulers, milk haulers, and transit buses.
A more recent development has found that we can produce renewable natural gas from purified biomethane. Once collected from using cooked grease from restaurants across the nation, biomethane is largely produced in the decomposition of organic materials. The anaerobic digestion of this material breaks it down into its simplest components, the majority of which is methane. Landfills, wastewater treatment plants, and livestock operations are the big players in this game. The Vehicle Technologies Office has identified over 300 landfills that actively produce biomethane, each up to 200,000 gallons of LNG per day. Large farming operations use manure digesters to produce methane that in turn powers appliances and provides other benefits to the farm. Only a portion of this power is used, which allows the rest to return to the grid, or in our case, remain as biomethane to purify for transportation fuel. Landfills and livestock facilities alike use this technology to power local natural gas vehicles such as refuse haulers, milk haulers, and transit buses.
In conclusion, natural gas is used to power various vehicles because of the relatively cheap cost and lower emissions. However, the differences in conversions from traditional fuel systems can present some challenges for running CNG to vehicles. And the lack of availability to the public and new implementations also produce challenges. And this can lead to a new development in fuel sourcing for CNG and LNG.